Welcome everyone, my name is Stephen Brooks and I've created the Air Insulated Substation Design course. I've tried to write the course to make it accessible to everyone, including people without an electrical engineering background. In the second part of this course, we will be introducing some more topics related to the design and operation of air insulated substations. Every piece of equipment inside a substation needs a unique number, and in the first lecture on this subject, we show how a typical numbering system can be developed. We start by establishing the basic principles before seeing how it can be applied to some simple configurations. In the second part of this lecture, we apply the numbering system we've developed to some more complex scenarios. We look at some bay examples before finishing with a full substation example. Interlocking is key to operating and maintaining the substation safely, and in the first lecture on this subject, we introduce all of the basic principles of how interlocking works. We develop the basic formulas for each type of equipment and then show how it can be applied to some typical substation configurations. In the second part of the lecture on interlocking, we look at a typical mechanical interlocking scheme. We start with basic principles before applying it to some typical bay configurations. Ring main units are used widely on the distribution network, and in this lecture we look at all of the key elements of this important piece of equipment before showing how flexible ring main units are on the distribution network. One of the main subjects of this course will be transformers. We start by going back to first principles and show all of the design features of a power transformer and see how the network that we connect the transformer to dictates some of its key design features. We then go on to describing what makes up a modern power transformer and look at all of the key elements that we need to consider when ordering and installing a transformer. Transformers generate a huge amount of heat, and we look in detail how we improve the transformer rating by dissipating some of this waste heat. We then look at some of the main transformer controls, which help us monitor the health of the transformer and make sure it's operating at peak performance. Transformer tap changers are used to change the output voltage of the transformer. We look in detail how tap changers operate and how they can be configured to deliver the voltage that we require. In the final few lectures, we look at how we install a transformer, including how we design a transformer bund and the firewalls that protect the substation should the transformer catch fire. Transformers can weigh up to 150 tons, and getting these important and expensive devices from the manufacturer to the substation can be extremely difficult. We look in detail how this can be achieved safely and also see how the substation needs to be designed to allow for the safe delivery of the transformer. Once the transformer arrives in the substation, we need to be able to get it safely from the haulage vehicle onto the slab. And in the first lecture on this subject, we see all of the key elements of how this needs to be done. In the final lecture, we'll learn in detail how the transformer is jacked from the haulage trailer onto the foundation, which can be a complex and dangerous procedure. I hope you enjoy the course and get something out of it. As usual, if something doesn't make sense, please feel free to send me any questions you have.